All right, so we'll get started on today's architecture meeting. Do appreciate Bill Munyon's going to take us through the work they've been doing on IETF related to the SCAP or at SACM. I can never figure out which one to use. Sorry about that, Bill. But he'll take us through that. We did get started on the last call. I assume, Bill, you'll just start from scratch anyway. We didn't get that far to level set those that are here that may not have been there the last time.
Yep.
Okay, so you can take control anytime you'd like, Bill.
All right, good deal. Let me just make sure I got all the things up. Here, this guy, start this amazing slideshow. So a little bit about, yeah, this shouldn't take too long. I have the kind of diagram at the end that'll hopefully explain a little bit more visually and kind of spark a little bit more of the conversation. So I'll kind of hammer through some of these slides because there's only a few. But so just a little bit of background. The Security Automation and Continuous Monitoring Working Group is one that's out there in the IETF that a number of us have been focusing on. And there's a nice little link there to the latest version of the draft for the architecture. It's initially focused on posture attribute collection and evaluation, which is very similar to the things that SCAP focuses on. Collecting the various information that conforms or not to security configuration policy recommendations. It does have, allow for capabilities that are beyond that. It's really more of an architecture for security information exchange, or really just any sort of information exchange. A lot of what the SCAP effort is focused on started in a sort of diverse set of requirements and different sort of architectural ideas. But as conversations moved on and the architecture kind of evolved a little bit, the SCAP architecture started to look a little bit like the SACM architecture as well. It's kind of got similar ideas and similar in intent of what it's trying to accomplish. I know that one specific thing around the SCAP work was really around sort of SCAP content, where SACM is kind of trying to be sort of content agnostic and integration service agnostic as well. We've done a little bit of hackathon work. The IETF, when they have meetings 3 times a year, they do a nice like weekend long thing where we get to sort of drink beer and write code. And we've done a little bit of work there for proofs of concept, utilizing some, as is noted here, simplified SCAP content, kind of easy oval objects to collect and sort of integrate in there. We've done work with different messaging and integration frameworks. We've done some XMPP-based implementations, some OpenDXL-based implementations. It's focused on really capabilities and operations. The capabilities really kind of define what a particular component can actually do within the ecosystem. Can it collect posture attributes? Can it perform log aggregation, persist information to a repository, maybe ingest other telemetry information from outside sources, or perform sort of observational-based collection, et cetera. The SACM architecture kind of allows for the advertisement of a component's capabilities, sometimes called service discovery or capability advertisement is the way I kind of termed it in the draft, when a component onboards and registers with the ecosystem. It does kind of create a bit of a dependency on a manager application that tracks the capabilities and kind of helps to, I guess, obviously manage that. When using OpenDXL, that association of those capabilities kind of comes into play with the various topic names that are used to connect to and publish and subscribe on OpenDXL. Given the particular topic names, the OCA ontology can then help describe, the operation type, whether or not it's a directed request response type of action or a broadcast event for publish subscribe type of thing. A little bit more information about the actual payload and the data model that payload would correspond to. And the OCA ontology provides all sorts of good stuff that helps with the different return codes or error messages and things of that nature when responsive. So as you can kind of see on the slide, something to the effect of what the manager would keep track of is a capability URN. So like if I'm a component and I have the capability to subscribe to collection events in the OVAL language, then that's my capability. And I can then be told as a component by the manager to say, subscribe to these particular topics and listen for those collection orchestration events, for example. There's another kind of example for OpenC2 to kind of, again, listen for that specific type of action and a payload. Some of the operations that are actually currently defined in the draft talk a little bit about component registration, how a component onboards and talks to the manager and says, here's what my capabilities are, and I'd like to participate in the ecosystem, the authentication and authorization part of that. It establishes what we call an administrative interface. This is really a directed channel and a directed topic from the manager to each component. So when a component registers, it gets assigned a unique identifier, and then the topics will be able to be set up kind of bidirectionally for the manager to talk directly to that component and the component to directly talk to the manager on that administrative interface. The capability advertisement then again goes over that channel. Basically, the component says, here's what my capabilities are. And given an OpenDXL-based implementation, for example, the manager would respond back saying, okay, I understand what your capabilities are. Here's the topics that you need to subscribe to. Here's the topics to which you need to establish a service listener for any directed queries. It also provides information about a topic, kind of a global topic for the ecosystem for status notifications, something that the manager can listen to and basically be notified of any status updates or any sort of information that any component would like to publish to that. And it's not necessarily just for the manager to subscribe to. Any component that wishes to know about somebody else's status can do that as well. And there's a bunch of information about the different aspects of orchestrating and going through the posture attribute collection and evaluation operations through that. So if I want to have the manager direct an orchestrator to say, I want you to perform posture collection, that orchestrator knows how to do that in OVAL. It will massage any of that payload to OVAL definitions or OpenC2 instructions or anything like that. Forgive me if I misuse terms for OpenC2. And then pass that information on to a collector who will perform that, or reach out to an endpoint to perform that collection, and then pass that back and persist that to a repository. So the draft contains a lot of good information about that, including a little bit of information modeling in there to say, like, here's the type of information that would be passed from component to component. All right, we'll show you the diagram. This guy and this guy. We've got to the diagram, and if anybody needs me to either zoom in or zoom out, I can do that to better highlight the flow here. I'm sorry, I don't necessarily think that I have like a point. Anyway, all right. So this diagram was pasted into one of the emails that kind of went out a couple of weeks ago, and just to kind of highlight a little bit, the orange component, the orange boxes here, anything along the outside of the diagram here, represent components within the ecosystem. So all of these components will come in and register. So we've got an orchestration component, an actual posture collector, a repository interface, things of that nature. This is actually red. This represents kind of in this case, the integration service, so an OpenDXL broker that's alive and sitting in that environment. Within that, an organization sort of boundary of responsibility, we'll call it. The sort of pink boxes here in the middle represent the various topics that are currently active and used by the various components. So given this, and I'll kind of go through the flow of this, and it kind of moves from top and left to right in sort of a nice sort of wavy type of workflow here. So given any of these components, and I illustrated it here with the orchestrator, this is when it comes to onboard, it's going to go ahead and request component registration on this defined topic, which is using kind of terminology from the OCA ontology, is a directed message. So it starts with the word action, and it goes to the manager from a component, and its purpose is for registration. So the orchestrator will publish a message on there saying, I'm here to register. I'd like to authenticate and go through. The manager listens for that request, responds to that component registration. So it's going to persist some information about that component, generate a unique ID, or kind of reinstate that unique ID if this certain component had registered previously, and it will respond with its unique identifier saying back on this topic. So the component is listening for that registration response saying, here's your unique ID. I'll talk to you in a little bit over that particular channel. So what's going to happen is then the orchestrator will provide its component, and it's actually not in this diagram, but it will, over that sort of directed channel, which is another request response, so it's an action to the manager from that component's unique identifier, saying, here's the capabilities I have, and tell me what I can do with those capabilities. The manager will again sort of do some administrative work, persist some of that capability information, and reply with the topics to which that component should subscribe. So it's going to come back and it says, okay, I can orchestrate collection using Oval. And so what that's going to happen, what that's going to do is then, dog sneezing, and so over that administrative interface, those topics will be given back to the orchestrator. The orchestrator will then subscribe to those particular topics. Then when collection is going to take place, then the manager will provide an orchestration request to the collection topic here. So it starts with notifications, publish, subscribe, to the orchestrator, performing a collection action. The orchestrator will be subscribed to that, so it will receive an event notification. It knows how to take those collection instructions, format those to a particular data format, which is Oval in this case, and publish those collection instructions, that's this guy down here, to the collection topic to which the collector is listening. So again, the collector went through that same component registration and is subscribed to this particular Oval collection topic. It will then receive that notification of the collection event. We'll go ahead and go off and perform that collection and publish its results to a persistence topic to which the repository component is listening to receive the notification of those collected posture attributes and be able to persist those into a repository. In the middle, you can see here, again, is the sort of status notification topic to which each of these components can publish, status updates, repository status updates, collection status updates, things of that nature, so that the manager can be notified of any of those. So a very long-winded story short, these components will all register to provide capabilities to the ecosystem. The manager will go through and publish requests or send requests to the appropriate topics to which the components are listening in order to sort of invoke those capabilities. And in this case, perform that oval posture attribute collection from the various computing resources, the endpoints, and persist those into a repository. I think that's pretty much it. I know that Adam's on. He can probably, maybe Adam's on.
So one question I have a bunch of questions on how this will relate to our other C4 diagrams, but let me get to that later. With the orchestrator, for example, could that be a SIM or SOAR?
Yeah, absolutely.
Okay. All right.
In this case, it's sort of logically kind of separated from here to say, like it can receive a sort of set of generic collection instructions, for example, and take those collection instructions and format those to a particular way that collectors know how to deal with. Whether that's OVAL, whether that's OpenC2, whether that's stick shifter, any of those different content formats.
Right, makes sense. And then the collectors, like in our use case example, we have a scanner on the endpoint and we have a scanner on the email systems. Those would be quote unquote collectors, would they not?
Correct. And like
Okay,
the SACM architecture kind of diagrams that in a couple of different ways, where there's sort of an agentless collector, something that can reach out and grab from a remote endpoint, or an agent sitting on that box.
Got it. And does the manager emit security events or have a syslog to talk to a SIM?
It certainly could. Yeah, absolutely.
Okay.
Any of those capabilities are certainly possible and not diagrammed on.
Okay, yeah, because I'm kind of thinking when I look at your diagram, it's kind of a lot of this will inlay into some of the components we've written up on use case, and some of them are unique components to the collection of the posture and the managing of that, like the repository interface, I think is one of them. But so I think, there's two things I'm looking at. One is, there's kind of as we build the architecture, there's kind of being a recommended set of things like a SIM, a SOAR, threat intelligence, whatever, has to do in order to kind of be plugged into this type of sub-architecture, I'll call it, that's dealing with posture assessment collection and queries, right? And then there's probably another set of things that we want to talk about in terms of how other systems like a SIM or other systems could listen for information. It's not a posture collection component, but it may be interested in context of the posture collection system has.
Exactly. I'm trying to find something here. I just want to, like, I can
Got it. Okay.
go something else as well. And I think and this is kind of slightly internal, our own kind of tooling, but you can, it allows you to see the sort of different components at play. So I have another diagram that I can bring over here. And this is kind of some tooling that we have, at CIS, and it sort of illustrates a number of different things where we've got what we call our SysCap Pro dashboard, and this can actually be used as, kind of, it maps basically to a manager and an orchestration component at the same time, and even a repository interface as well, where it knows the language that our assessor, which is a collector and an evaluator, knows how to speak. So it can perform the functions of a number of those different components and use those the different topics to perform that as well. So these topics basically serve as a very similar kind of mapping. If I were to move these over side by side, you can sort of, at least internally from our kind of organizational perspective, where a number of these topics map over into these different the different topics here, as well as the different components. So this large blue box here on the right hand side kind of maps to a number of different components, both manager to orchestrator to a repository interface.
I see.
And
Good. Okay.
the service acts really as the collector in that case, and publishes all the rest of the stuff back to that component. We have some external stuff too.
And is there any concept of like a microservice or something? And if I was like a scanner, kind of like the two examples I gave you, I can kind of use your collector microservice, if you will, to talk SCAP, SSASM for me rather than me having to kind of adapt it. Is there some way
Oh,
to
sure. Yeah,
Yeah.
definitely. The kind of the idea behind it is that any of these could be either large applications that perform multiple functions or individual services to perform whatever it needs to perform. Absolutely.
Yeah, I'm thinking more of the latter, right? For the technologies we're dealing with across the current we have with all the different existing technologies, I want to make it easy for people to just talk the language and just easily plug into this architecture rather than have to learn all the sophistication of it and keep up with all the versioning of it
Yeah,
and things like
exactly.
that.
Really, the main interfaces that it would need to kind of talk to is the ones that are specifically named in the kind of in the diagram. It would need to be able to
Okay.
register. It would need to be able to establish a unique identifier to communicate back and forth if that's even necessary. Really a status, and then from there, it's really implementation dependent on what other topics would need to be configured. So there's at least in the SACM draft, there's a very minimal set of kind of required topics to be, and actually it doesn't even specify anything as granular as a topic name. So it is actually broker agnostic. So there's some that like XMPP is more payload based than it is topic based. So kind of makes that even more generic.
Okay, but if we're going to rely on the OCA architecture and OpenC2, would we try and kind of lay out
And I think that's where they
the
like the OCA ontology would come into play, would be able to
yes.
define those specific topic names and the payloads that would go over those topics.
Okay. Topics and payloads.
Absolutely.
Okay. Yeah. And I would love to have if it's available, just to if I'm a collector, here are the topics and payloads that I can be expecting to deal with, and if I'm a orchestrator, you know what I mean? Because we
Yeah.
have across the membership different places that things are going to plug into, and I'd like to understand what they got to do to listen and play in the environment.
Yeah, absolutely.
Okay, great. That would be useful.
I think we also, sorry, it's Adam. I think we also have questions about this overall, like, so the diagram on the left with the orchestrator, especially after hearing Mark talk a lot about event-driven architectures. I think he dropped off the call, unfortunately, but
Yeah, I don't see him anymore.
is there some opportunity for us to make this more efficient? Right. So like if we assume event-driven architecture, does that obviate some need for an orchestrator at all? I don't know the answer to that. I'm just kind of putting it out there. And if anybody else has comments on this as well, right? Like we're trying to come up with something that's relevant, right, and useful and efficient and easy to
Yeah, I think
implement, easy to operate.
Sims are examples of event-driven systems. That's all they get all day long. You know what I mean? And so I think that's from my listening to what he said, Alan, I think it's a method. I don't know if it's the only one, because orchestrators are also people driven a lot. At least the SOARs are, right, in terms of workflows and driving actions and hunting things and getting context. And there may not be an event around that you can tie it to. It may be some indirect thing that they're doing that drives their actions, and I'm not sure you can tie it to it. So I think event driven is a part of it, but I don't think it's going to be exclusive.
That makes sense too.
Yeah.
I mean, we're hoping, I think Bill can help me tell the truth here, but I think we're hoping that we can wrap up this SACM draft probably sometime this summer, late this summer, probably.
That would
I
be
want
nice,
to
yeah.
roll through it, get it done, and then we can start. Well, we do this in parallel, start implementing something. But
Yeah, and I think
guess
so.
that's
Back
the
to what Bill
intent.
said. I think the OCA ontology will be the basis with which we'll kind of, lay this in. Yeah, and that'll help us figure out how to orchestrate across the different components that we've been looking at.
Yeah, I think for us, like when it comes to just kind of defining the I guess agreeing with what Adam was saying about kind of with the draft and in the working group and stuff, is that once that's kind of laid out, then we can really kind of work with the hackathons in that space, and some of the other kind of community work we can do here to have an OpenDXL based like implementation of that of this, and really
Yep.
kind of see where the gaps are and if like edits need to be made and things of that nature. So like it hopefully will be able to drive a lot of implementation work.
Yep. Yep. No, that'd be great.
Any other comments or questions?
One quick question. So the computing resources in the diagram, the very bottom left, which is what we're observing with the architecture. Could these computing resources be servers serving workloads, or is the focus on client-side computing resources, laptops, PCs, desktops of the employees, etc.?
The idea is to keep that as generic as possible. So I think that all of the things that you mentioned are those that could be qualified as computing resources. So that could be, a Lambda function. It could be, a CloudFormation template. It could be a Docker container. It could be, a laptop or a server. All of those things.
Got it. Okay, thank you.
Sure. Great question. Thank you.
So I know the things I want to do with this, Bill, is to take our other C4 diagrams. Let me share the one I'm talking about here, and see if we can lay them together. Hold on, let me show you what I'm talking about. Remember this guy? There you are over here, Bill. There you are. I didn't know how to lay it in here, but I'm almost thinking we can overlay you have a collector. I mean, we should put a little gray box in here, the collectors. I want to kind of overlay your architecture inside of this. Right, here's the source system, the orchestration. Here's the threat intelligence system. Here's the SIM system. So if we could take your boxes and then write color coding, can make it consistent for the patch collection system, and lay them inside of these things. And then what we could then do is, you talked about the ontology, the tropics and things. We can kind of, in these yellow boxes, lay out what those are. I think we could get a good feel of how we can take our components like the SIM-SOAR threat intelligence engines, and then the scanning engines like the endpoint or email scanners, and lay in the SCAP stuff and how it fits. Does that make sense?
That does make sense. And I think that we can probably take a bit of the C4 diagram that Adam and Mitch and I had as well. So I think that will fit very nicely into your diagram here too.
Yeah, absolutely. I agree. We've got to go from both ends, because when I finished looking at the C4 diagrams that you guys did a great job on the system, it was a really good description, and you get another excellent description of the system itself, SACM, and how it all fits together. And now we're just trying to edge it into these other systems, and that's where I'm running into all these questions. As you can see, I started writing them down. You know, do you have a syslog, right? I've been asking Adam about stick shifter because a lot of the things we do is stick shifter based for queries, so that kind of stuff.
Gotcha. Yeah, we should be able to.
Okay.
The components definitely fit into the diagram.
Yeah. No, as you're doing yours, I think I could even take a shot at. If you'd like, I'll take a shot at this one, given your picture, and put those boxes inside where I think they go, and then you can fix them.
Yeah, that sounds perfect.
Right, and then you could take the ones you guys wrote up, and then take a next step of that as a step forward to bring in what you have there to those diagrams. I think that would be good.
Sure.
Is that good? Okay.
Yeah.
Yeah, I think that would help because what I'd like to do, and I think Adam, you and I talked about this, is eventually get to a picture, around the use case one where as a prototype, back to the prototype project, right? We can prototype this stuff and connect everything together and just do a very basic malware detection example where all these components are communicating the ontology using stick shifter and the NSCAP, right, and the ontology itself, which would be very powerful to show all of our stuff kind of working in concert for the use case.
Sounds like a plan.
Does that sound like a plan? Then you can close out your summer draft for SACM, and I can close out the first architecture draft for OCA. That's what I'm thinking.
We like completing work.
Well, I'm with you, Adam. I want to show something running. This stuff. So anyway, that's what I wanted to do. Just that was my comment. Anybody else welcome to comment next? Just wanted to get that in. Oh, we got Mark back.
Yeah, I'm here. Sorry about that.
We lost you.
No, but for what I did see and listen to, it's great work. I think I still, I'm thinking like we need another piece to have a really good kind of prototype, demo environment. I've been thinking about these ZTNA vendors that I've been working with, companies like AppGate, Access Security, TransInX, that could be brought into this, where a threat event takes place, that could affect posture, or maybe some configuration or vulnerability could affect posture, and that changes status of a consumer of that kind of thing, like a ZTNA would, and kind of, just slightly extending the end-to-end flow with the pieces that we have here.
Yeah, certainly, Mark. I mean, the use case we're looking at with malware detection does that, right? It does.
Yep.
It does change the posture. It does cause threat intelligence systems to react, to collect information context around that event. It does collect, create SIMs and source to do things. So yeah, absolutely,
Yep.
Absolutely. And then Adam, you had a question. I think we may have lost you, Mark, in the question Adam asked about event-driven architecture. And he was asking about that and what your thoughts are on that and how that would fit.
Oh yeah, sorry about that. Yeah, I think really the effect it has is just looser coupling in the architecture.
Good.
Where there's not, as few one-to-one relationships as possible. That, something has to maintain state somewhere, and something has to, store events that occur somewhere. But I think we could apply it and define some flows, kind of given when then, given the state of the system overall, or posture, or a new threat event, whatever that might be. When some other thing occurs, then do something.
Yeah, that makes sense. I was asking the question specifically about, because in the diagram we have something called an orchestrator. And I guess if that's really more of a role that something plays than anything else. So like a SIM could be
right,
play that role of an orchestrator. So there could be events coming out of that orchestrator. It's not necessarily, it's not the puppeteer, right? It's really something that generates the appropriate event given when something happens, then it might generate this other event, which is a given when then for something else, right? So
Exactly. Yep.
my question was really more like, okay, do we actually get out of orchestration, or is it really just kind of changing the nature of it? And I think it's more changing the nature of it.
Yeah, I agree. I think it's a continuum from, you know, manual processes to orchestration to, you know, what I've heard somebody else smarter than me call choreography, to full automation at some point. You know, choreography, there doesn't have to be a man in the middle like pushing buttons. It's more of like a dancing with somebody, and there's a lead and, you know, somebody following, and they just move smoothly. And I think that we don't have right now the mechanism to implement that. And what I've often thought about is, as we further this architecture, something I'm still desperately trying to get McAfee to open source, this integration pattern engine that we have. It's kind of like a stream processing, or, you know, man in the middle kind of technology with connectors and plugins and patterns that can be defined. But I think we need some, you know, concept of an app, and that the connector itself between a bunch of APIs or event topics or, you know, whatever it is that something has, and the open ontology architecture, like in that connector, defining the business or the logic that, you know, I have these type of events, I have these, I can see these type of things, I know these things and produce this type of intelligence, and I can take these actions. And then given the other things in the ontological architecture, defining, you know, what are the things that I'm interested in that I can subscribe to, and when that thing happens, I can derive state from somewhere, and then I can just take my action. You know, distributing the orchestration logic, or the if this then that logic, if you will, and further out into the architecture, I think, you know, to enable higher complexity, higher volume stuff.
Makes sense.
So another question I had, Bill, on this was, you know, the posture collection system seems to fit nicely for like what I call units of work, like a, you know, if there's a particular thing you're checking posture on, like a endpoint, right, or a server. It's not for a collection of things, right? You're not looking at the posture of an overall micro network or something, or an overall IoT environment. Are you? It's a unit kind of based system, isn't it?
That would depend on the collector.
Okay.
So if perhaps the collector is located at that endpoint, or you know, listening to that to one particular IoT device, then yeah. If there's for example, an agentless collector, then potentially those collection instructions would indicate the range of computing resources to pull those posture attributes from.
I see. Okay, so something could kind of proxy all of that and bring it together. I see.
Right. If you know, you could tell a particular collector to collect a you know, a registry key from all the Windows machines on a given subnet.
Gotcha. And the reason that was in my head is because I've been doing some work on our architecture against XDR is a good example. XDR is really a composite of endpoint, network, cloud, and so, you know, there's an XDR posture kind of quote think in my head about it's really all of them together. It's not just one.
Yeah, I think that's spot on. I think also, you know, being agnostic of the collector at the endpoint, you know, it could be OS query, or it could be some EDR tool. It could be, you know, purpose-built vulnerability assessment, scanning thing. But yeah, like trying to further decouple that part of it from the overall architecture and who can use that thing.
Yeah, can we put Bill's diagram up again?
Encore, Bill, encore.
Yeah. So I know when we were talking, all right, I'm looking at the collector and the computing resources.
Yeah.
When we were talking about the, SACM, I'm not saying the SCAP V2 architecture, we were saying that that interface from the collector to the computing resources was not defined. So,
Okay.
like you said, you could have any kind
Yep.
of product that was doing that. But when we were defining the architecture, the messages from the integration service to the collector were standardized. So I think that fits in. You could, as long as you define what instructions you're sending to the collector and what responses you're getting back, you don't care how it accomplishes it or what the granularity of the computing resources are.
Yeah. And I think, pulling that out, that specification, and saying that, OCA, we think that whatever the collector is, it should expose or publish this at minimum. You can do whatever you want on top of that, vendor
Right.
XYZ, but if you're a sensor like this that has this visibility, you should make this available to an open cybersecurity architecture.
Right. That's right. That's right.
And I think once we have like, a handful of those kind of upfront design rules or whatever we want to call it, that that'd be something we could publish and make hay about with the prototype.
And just a random point, I know at the beginning, Russ, you were saying that one topic might be an OVO collection and another might be OpenC2. They aren't really aren't really peers. OpenC2 is, a framework for getting actions or requests and responses back and forth. And so there's an OpenC2 message that has, to and from and timestamp and request ID. And you could use that, the to would be a topic if you're using a pub sub.
Right.
And so mapping these topics to OpenC2, endpoint addresses, and then mapping the payloads to OpenC2 content. The content can be anything. You could have a register action, or you could have a collect action. And so all OpenC2 sort of is a message structure for translating the ontology into bits on the wire.
And I imagine the content you just described, David, would be something we would put in the OCA ontology to define exactly what that content is or looks like.
Right. Well, there would be a set of rules, I think. We'd need to work through some use cases.
Yep.
But once you develop the ontology, and that's the source of truth, the single source of truth about the architecture.
Right.
And there would be rules for constructing open DXL messages from the ontology, and OpenC2 would define payloads that would implement those actions.
Right. Okay.
Where they can be related is that you might have a single connected thing, a sensor or an agent or something that could both do posture assessment or collection of things that lead and postures derived from. And that same thing might also be able to take some of the OpenC2 defined other actions and remediation things, and that connector to that thing that can do both those things needs to be able to map or implement the ontology. I feel like we need like some sort of like centralized schema registry.
Yes.
That's, you know, we kind of have that with topics in OpenDXL, but something that, and you know, Kafka has Schema Registry or Zookeeper or something, and you know, different things have their own thing. We need something that's a level above that.
Yep.
That an orchestration automation response tool could sit on top of.
Yep. Yeah, that makes sense.
I really like the SOPA architecture in the way that I think it was ESG published that, but it was like security orchestration and analytics platform architecture. And the way they defined the stack was pretty good. This is great work. I think we need some place to a shared development environment where we get building some things.
Well, yeah, well, I think we'll get there, but I think we still need to kind of spec out how this stuff overlays each other, right? So we understand, as an example, as a collector, what their responsibilities are to the architecture here, right? Otherwise, you know, if today's collectors, like we were talking about before, and it's in the use case, we've got an email scanner. I mean, that's a posture assessment type system that he would call a collector, and we've got an endpoint, right? An endpoint solution, which could also be a posture collector. And we've got to lay it out so when they publish back their results of posture information, it's properly reflected this architecture versus the way it runs today, right? Which is going to be independent from a query from some other place. And then coordinating those two and synchronizing those two would be a nightmare. So we got to make sure that if you start talking this architecture, we do it consistently. So the information is together. Because I can see a use case here where I'm an endpoint. You know these things, Mark. You're an endpoint solution, and you always are sending posture information independently of this architecture to whoever asks. So we got to somehow make sure that it plugs into this collector architecture here, so that information flows properly, and then the data that's pulled together is consistent.
Yep. Okay. I think that makes sense.
Yeah, especially when we're talking endpoints, we're talking thousands of them. You know, so that's where I worry more about that. You know, that case, which happens a lot.
But posture primarily is focused on, like, you know, configuration, you know, patches, policy, vulnerabilities, things like that, right?
Our use case is a vulnerability, right? It's a malware threat. That's a vulnerability, right?
Yeah, I think we can separate the posture and the vulnerability from a threat, though, and an email sensor, if you will, that could detect threats might have an event that the posture calculation comprehends, but isn't directly a posture collector.
Although if you look at the use case, right, the vulnerability introduces some posture exposures.
Right.
Right. So we're right into we need both of those pieces of information pulled together to correlate, for one thing, right? You know, what the malware is doing and how it's affecting posture on different systems. And if you go through the explanation of that email malware that we talked about, it does you know, trying to do the normal malware things, which will create posture exposures in other systems. And that's why I was worried about multiple systems, because, you know, that's what happens. It starts with one, but it quickly spreads.
Yeah, lateral movement.
Yeah, absolutely. And that's kind of what the use case is, right? Good. No, this is good. This is good. It's very helpful, Bill. It's very helpful to get to this level of detail.
Mark, yeah, that's great. I'm glad that the conversation was good. It's what we were hoping for.
Great. So I'll write down the next step, Bill. You and I are going to work on some C4 diagramming. I'll take the one I had from the use case I showed you, and if you could take one of the ones you and Mitch and Adam did, and let's see if we can meld this in there.
Sure.
Okay. That'd be a good next step, because I do want to get to the point where we've got a good understanding of how, which I don't have right now, of how this architecture fits in with the others that we've mapped, which is the ontology and stick shifter. We didn't do a good job on this one because I didn't understand it enough. So let's get that in there properly. So that's the next steps on this. Does anybody else have any other topics we want to cover the next meeting? I know we only got a few minutes left, but how we doing, Andrew, on the threat side? Are you making progress, or you need some help, or?
I'm doing okay. I actually put up one of the use cases I've got. It's kind of long-winded, but I figured it was a start, talking about threat intelligence platform and how it can connect to SIM. Just kind of example. Let me put a link to that up. I haven't opened the PR yet on the documentation stuff, but partially because I don't know what happens when we put a PR up. Let me.
Mark's on the call this time. You probably did the PR in last time, did you, with a build issue? Did that get resolved?
No, have not heard anything on that yet. Actually, if you said Bill was the one guy.
Mark's the one. Remember you're trying to get a hold of Chris Smith,
Mark,
but Mark is the guy we needed. Mark's on the phone, so you want to review?
Okay.
Well, yeah, just real quick while he's here. Yeah.
Yeah, there was some funniness with the which repo was it? It's the one, the OpenDXL ontology site that like auto generates the pages in GitHub Pages. Looks like that build is broken.
Okay. Yeah, no,
there's some
I actually
permission issues going on there.
Okay, I'll ask its author to take a look at that. Chris, I've recently gotten him re-engaged, and he's going to help with some of the OpenC2 and merging some of that into the ontology, beyond the high-level examples that are there. So
I actually forked that repo and fixed the permission issue so that mine is building correctly. And you should be able to see on my like mirrored GitHub Pages thing the results of that if I can help out with that at all.
Yeah, absolutely. I'll go check that, and
Perfect.
I think that I can make that PR. If not, I'll get Chris to do it.
Thank you, Mark.
Yeah, so the only other thing I've got is just this very simple initial C2 case, or it's not C2, tip case here that I'll drop in the chat.
Okay.
That's just the diff.
Alrighty.
Yeah, sorry in advance for it being kind of long-winded, but that might be a discussion point for next time. I can continue to update.
We'll start. We'll just kick it off with this conversation, if that's okay with you, and dive into this a little bit deeper.
Sounds good.
So thanks for doing it. Yeah, you got good use cases on the threat side. Perfect.
But yeah, I would love if anybody has comments on that, especially there's a lot of stuff there I kind of just dove into, and I was like, well, let's try all the things at once, and some things may need to be simplified and broken out into different use cases.
Perfect. Thank you for that. That's excellent. Yeah, I'll take a look.
At first glance, it looks great. I really like, I think one of the things with the event-driven event modeling methodology is really a focus on the user in the upfront design of the distributed system, and keeping the persona in there is, I think, critical.
Yeah, there's a lot of stuff, especially when you're talking about things, and I'm sure we'll experience this a lot when we go into SOAR, because the automated systems are going to be running playbooks and things, but overall it should kick off with actions to or from users, even if there's a lot of stuff going on in the background that they aren't necessarily cognizant of.
Yeah, absolutely. What do you make visible or a view, and then when or what decisions do we want them to make based on it, right?
Yep.
All right, that sounds great. So I'll put that on the Andrew. I'll put that on the top of the agenda of our next call, and we can go through this and get some feedback and see some of the use cases of threat intelligence personas taking.
Great.
Okay.
You had a question for Mark before we break.
Yep. Go ahead. Yep.
You mentioned something called the Security Orchestration Analytics Platform that you liked. I did a Google search and found a Securonics company with that. Is that the product that you're talking about?
It's not, and it's not a product. It was a analyst
Category.
group.
Yeah.
ESG, I believe it is.
Ah, okay.
Actually, there's an OCA related. I wonder what happened with that. Jason was doing a interview or a briefing with an analyst from ESG that authored the SOPA architecture kind of paper.
Yeah, he did do that. It was with John, wasn't it? Yeah, he did do that. I don't think I've seen it posted, but he did do that.
Yeah, so that's the actual guy that authored it. Let me find it. I'll put it in the chat.
Was it John or somebody? Yeah. So no, it's not a company. It's an architecture.
Yeah, so ESG-global. I'll put it.
There's a link in the chat already. Bill put it there.
Oh, nice.
G Global. There it is. Yep. I see it.
Great.
SOPA.
And I've got some kind of good architecture slides that somebody made that I've reused many times to show customers or partners, a pretty picture of kind of how the different things integrate together in those SOPA layers. I can share with everybody.
Yeah, that'd be great. Yeah, see John's picture in the videos on the link that Bill sent.
Yeah. Okay, thanks.
Okay, excellent. Well, thanks everybody for joining. And
sorry,
thanks
hey-
for a very productive discussion.
Hey, Russ, one more thing. Sorry to
Yes.
keep everybody. It's a huge favor to ask, but it would be very helpful for the SACM draft if you guys would be able to potentially, if you have time. I know that's a lot to ask, but if you could read the draft and join the list and comment on it, that would be super helpful to us. Like, even if it's just like, hey, this is in the right direction, or we can see how this is useful, or whatever comments you might have, that would be helpful for us.
Is that the link to the IETF that Bill sent? Is that the one you're talking about?
I have two links in the chat right now. The first link that I put in is a link to the draft itself, and then the second one is just to the mailing list sign up.
Oh,
basically.
I missed that one. Okay, and that's the one you're asking us to sign up on. Okay, gotcha.
If you can, like, I'm not going to twist arms or anything, obviously, but it would be extremely helpful.
I always like to help you out, Adam.
I'll do it, and I'll see if I can get anybody smarter than me at McAfee to also check it out.
That'd be great. Thank you.
All right, everybody. Thanks again so much for the call. Sorry, I went over a few minutes, but a very good discussion. I appreciate you guys for being prepared and having a good conversation. Have a great eve.
Yeah, likewise.
Thanks,
Yeah.
Russ.
Thank you. You too.
Bye-bye.
Bye.
Good one, guys.
Bye-bye.